I said that the fundamental theorem of calculus has part 1 and has part 2. We do know part 2. Part 2 is the integral from a to b from f of x dx. This is equal to capital F of x from a to b, exactly what we've been practicing, and that equals f of b minus f of a. This was done, right, some time ago. What I did not get the chance to talk about is this. Okay, let's talk about it now. That's the last thing, the last new thing. Everything else is completed. So the fundamental theorem of calculus, part 1. Fundamental theorem of calculus, part 1. Okay, let's look at a continuous function, f of x, on the interval a comma b. So here's my function. Here's the interval a comma b. And this is my function f of x. Is this function continuous on the interval a comma b?
Yes.
It is. Okay, now I will say, and I hope you agree, that this entire area under the graph, this, can be expressed how? The limit of the Riemann sum is one way, but since we're talking about the fundamental theorem of calculus, I want to go ahead and do from b f of x dx. We know that now, but you're right. It equals the limit of the sum of delta x f of x I. Correct, from I equals n to 1 to n, and then n goes to infinity. Absolutely. But since we are past that, and we're talking about integrals, then I'll say this is the definite integral. Good. This we know. There is nothing new here. Now, here's what I would like to do. I'm going to say that this is t, this is f of t, this is the interval a comma b, f is still continuous, so this is a function f of t. And this time, I am going to say that I have x. X is between a and b. And I want to say x is here. And I want you to help me express this area. Just this. Please tell me how to express this area. Careful. Yes? Good. Now, I'm going to call this area 1. Okay, now I'll say x is here. And I want you to determine or tell me how to write this area, which I will call A2.
Same thing, right?
Absolutely. Now I want x to be here, because x can be anywhere between a and b. And I want you to give me this area, the blue area, which I'm going to call A3. And I can go on forever, right? So for any x I pick between a and f, if it's here, or 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 anywhere between A and B, what am I really creating? Careful. So I say, here's X, here's Y. For this X, I get this Y. The notation is all the same, but the areas are not the same. So it's A1, which is a number. So for one X, I get A1. For another X, I get A2. For another X, I get A3. For another X, I get some other value. For another X, another value. What am I creating every time I pick an X and I get a Y value? I pick an X and I get a Y value. What do I create when I do that? A function. Very good. We are going to call that function G, and you have to tell me what type of function is it. What does it depend on? One more time. For this X, I get A1. For this X, I get A2. For this X, I get A3. What does G depend on? X. Very good. And it is the integral from A to X from f of t dt. I still haven't finished. I still did not explain what the fundamental theorem of calculus part 1 means or tell us or is telling us. Okay? So for now, I know that if in an integral I have a number as the lower limit and x as the upper limit, I'm not getting a number as the result of this, but I'm getting a function. Okay? So this is a function of x. Good. If I'm getting something like this, no one can ask me to evaluate the integral. That's not what we're trying to do here. So what we're trying to do here is the fundamental theorem of calculus part 2, part 1. Here's what it means. In plain English, we discussed this, but I didn't tell you that it was part 1. Differentiation and integration are very good. And how do I illustrate this? I illustrate it with this function. So I'm going to copy that function right here and illustrate the differentiation and the integration are inverse operations. So all I can be asked to do with this is find G prime. Nobody can ask me to find G because G is a function and it's defined as an integral. So this is it. I define the function that this time does not have sign in it, does not have a polynomial function in it, doesn't have a rational function, doesn't have log, but it has an integral. So now I'm asked to find G prime. What should I do to both sides of this equation in order to get G prime? I have to what should I do to both sides of this equation to get this?
Differentiate.
Of course. Let's differentiate both sides. The left-hand side is G prime. What about the right-hand side?
So, isn't it capital F of X or is it?
No, it's just f of x. Now, because of course this will eliminate this and this. All we have to do is just plug in x. What if I don't have x here? Let's say I'm given a function as the integral from a to 4x squared f of t dt. Can anyone read the inner function? It's no longer x. What is the inner function now? What is the function that I will replace t by? It's 4x squared. So here I should have multiplied by x prime, by the chain rule. But how much is x prime? 1. That's why I didn't put it in. So now when I'm asked to find, g prime, and I differentiate both sides, I have a slightly different situation. G prime equals f of 4x squared times the inner function prime, 8x. I want to work on this now with examples. On page 394, I would like to go through 7 through 18. And also 55 through 59 on page 395. Ready? Please choose. Notice that the fundamental theorem of calculus only shows that differentiation and integration are inverse operations. And remember, we have not talked anything about this number. This number can be anything. This can be x or any function, but this must be any number you want. It doesn't matter. It will not affect anything. So let's choose. The second set is slightly more difficult, but not difficult, really. So let's choose from the first set first, and then the second set.
Not 18.
18 is a good one. So we have 18, the integral from, so this is y equals sine x to 1 from the square root of 1 plus t squared dt. Let me draw your attention to something here, which is g is our y. A is not a number. But I know that a definite integral has the property that the integral from a to b from f of x dx is the opposite of the integral from b to a from f of x dx. So that can be fixed and put minus in front. This is my f of t, which I never do anything to unless I plug in something. And this is the dt. So now we're asked to differentiate. But I cannot differentiate just yet till I rewrite it like this. Now I can find y prime. That's all I'm asked to do. So I didn't read the question, I'm sorry. Use part 1 of the FTC to define the derivative of the function. So now the function is defined as an integral. And I know that when I differentiate an integral, I get a function.
The second part, this is dy dx, right? Or dy dt.
So you mean the y prime? I differentiate this side, I differentiate this side. So minus is outside. What do I get?
1
The square root of 1 plus
sine squared.
sine squared, very good, times the inner function prime. This is it.
So the y prime, is that dy dx?
Yes. But in this case, we are differentiating an integral. So that's why the integral disappears, and I have the function back. But if this were x, plain x, I would have had just a function. But since I don't have plain x, and I have to plug it in, and then I have to differentiate sine x. Okay, let's say 14. You choose the next one. So this is h of x, which is the integral from 1 to the square root of x z squared divided by z to the fourth plus 1 dz. We're not evaluating the integral. We are only differentiating both sides to determine h prime. Think for a moment and tell me what to write.
X over x squared plus 1 times.
So when I differentiate, I have, yes, indeed, when I plug in the square of x and I square that, I have x over x squared plus 1, I agree, times,
1 over 2 squared plus.
that's it. Let's work on 13. So it's again h of x, the integral from 1 to e to the x, and it's applied to natural log t dt. This is a function. We're not asked to evaluate anything. We're asked to find its derivative. So please tell me what we get on the right-hand side.
X e to x.
Careful. Yes, you're right. But I have to write natural log e to the x multiplied by the inner function prime. And then I know what natural log e to the x is because I have to bring x in front. And how much is natural log e?
Is 1.
Good. Times e to the x. All we're showing here is that differentiation and integration are inverse operations. When we differentiate an integral, we get the function. That's all it means. 17. Y equals the integral from 1 minus 3x to 1, u to the third over 1 plus u squared du. 1 minute. Bless you. So there is no more new material. This is the end of the class. We just practice now for the test and for the final.
Yeah. Yeah. So you get a negative integral from 1 to 1 minus 3x. But remember, you're taking the derivative at the end, so you get a negative 3. So it becomes a positive 3. In the end result. So you get a positive 3 times 1 minus 3 to the x cubed over 1 plus 1 minus 3x squared.
So how do you know when to flip them? When the x is in the bottom?
The fundamental theorem of calculus part 1 requires the lower limit to be a number.
Oh.
If the lower limit is not a number, you cannot use the property.
Gotcha. Okay.
You cannot differentiate. So I have to rearrange because the number is not at the bottom. So this is negative in front, 1 to 1 minus 3x, u to the third, 1 plus u squared du. And now I'm ready to differentiate. I differentiate the right-hand side. I differentiate the left-hand side and now the right-hand side. Minus 1 minus 3x to the third over 1 plus 1 minus 3x to the third multiplied by the inner function prime, which is? So therefore, these two negatives go away, and I'll put 3 in front. So then y prime is 3. 1 minus 3x to the third over, oops, this is second, sorry. And 1 plus 1 minus 3x to the second power. We'll have more applications of this. Okay, ready for problems 55 through 59? Please choose, or I will.
56.
56 it is. Actually, I was just looking at 56. So g of x equals the integral from 1 minus 2x to 1 plus 2x from t sine t dt. And now you could say, or you should say, wait a minute, where is the constant here? And I will answer in the following way. We know the definite integral has a property that the integral from 5 to 10 of course, f of x dx is the integral from 5 to 7 from f of x dx plus the integral from 7 to 10 from f of x dx. Do we agree with this property? Okay. So therefore, I can break, since it doesn't matter, I can break my integral anywhere I want. And I'm going to say the integral from 1 minus 2x to anything you want from t sine t dt plus the integral from that, whatever you want, the same thing, to 1 plus 2x from t sine t dt. And now I will say this integral is fine, but this one still needs work. What do I do to this one? Yes. I will say negative the integral from whatever you want to 1 minus 2x t sine t dt plus whatever you want. You can put 0, of course, any number you want. 700, whatever you like, because it doesn't come into play at all. And now I'm ready to differentiate. So now when I differentiate this side, I will differentiate this side. And I get g prime. Yes, I differentiate a sum of two functions, but I know how to differentiate a sum of two functions. So what do I get? Negative
Negative 2x.
1 minus 2x times sine
I thought this was hard.
1 minus 2x times the inner function prime, which is
1 plus 2. Well, wait a minute.
negative. Good. Plus,
1 plus 2x.
right, sine 1 plus 2x times the inner function prime. Good. So I will just rearrange it a little bit. You cannot do any simplification. I would just put negative 2 in front. So I have 2, 1 minus 2x sine 1 minus 2x plus 2, 1 plus 2x sine 1 plus 2x. Okay, before we look at more application of this, in part 1, I would like to choose another. This was 56. Okay, I will choose 59. 59 is y, the integral from cosine x to sine x from natural log of 1 plus 2v dv. 2 minutes. If you need help, please let me know and I'll come over. This problem, a couple of applications, and then I like to start reviewing. So, do we need more time? Sarah, you need more time? Okay, I'll wait. Okay, what is the first step that you will have to perform?
Splitting it, like
Yes.
the last one.
Cosine to what you want. What do you want?
0.
Fine. Natural log 1 plus 2v dv plus the integral from
0.
2 sine x from natural log 1 plus 2v. Again, this is not good enough. It's good. It's a step forward, but not good enough. Not ready for integration.
Negative.
Negative the integral from cosine x natural log 1 plus 2v dv plus the integral from 0 to sine x natural log of 1. Ooh, sorry. Good. Now we're ready to differentiate. The left-hand side is y prime. The right-hand side is negative
Natural log of 1 plus 2 cosine x negative sine x.
multiplied by negative sine x. Excellent. Plus
Natural log of 1 plus 2 sine x.
perfect. I just have to rearrange it a little bit by multiplying here, and I will write the final answer is sine x natural log of 1 plus 2 cosine x and plus cosine x times natural log of 1 plus 2 sine x. So what we have to remember is that functions can be given in the form of an integral, and it's still a function. So I have a couple of applications on this. So for example, 62, I would like to look at. If f of x is the integral from 0 to sine x from the square root of 1 plus t squared dt, this function is given to us in the form of an integral, and g of y is the integral from 3 to y from f of x dx, find g double prime of pi over 6. First of all, I'm looking at what I'm asked to determine. I'm asked the second derivative of g. I have a function, which is g, and I have to find its first derivative first in order to get to the second derivative. Okay, So then I will differentiate both sides. And please give me g of y. I'm sorry, g prime of y I meant to say.
G prime of y is f of y times y prime,
Which is?
which is square root of 1 plus.
Not yet. So this is just, oh, no, absolutely not. So this does not exist right now. I'm only asking what is g prime. Nothing else. You don't know anything about f for a moment. So then g prime of y is? So we differentiated this side. When I differentiate this side, what do I get? When I differentiate this.
You get f of y.
Right.
F of y.
Times y prime if you want, but y prime is 1. Because this is the variable in g. Right? So g prime is f of y. Good. I am one step forward. But I'm asked to find g double prime. So what do I do to both sides of this equation now? Again, right? So I have to differentiate both sides. So the left-hand side is g double prime of y. Now I will replace. Can anyone give us f of y? What do I write in here replacing this? I have to replace this by something. Can anyone tell us what to replace it by?
F of y.
Right. Please, yes, please give me f of y.
The integral from 0 to sine y.
Very good. From the square root of 1 plus t squared dt. Very good. Good. Now I know what to do with this. What do I do with this? The square root 1 plus sine squared y multiplied by cosine y. Now I'm ready to find g prime, double prime of pi over 6 because I have the expression. So then g double prime of pi over 6 is the square root of 1 plus sine squared of pi over 6 times cosine pi over 6. But I know what sine pi over 6 equals to. It's the very first, the smallest angle and its sine. And that is what? 1/2, right? Good. So then I have the square root of 1 plus 1/4 because I have to square it. Times, what is the other number? That will be cosine pi over 6, which is? Very good. So 4 plus 1 is 5. So this is the square root of 5 over 2 multiplied by the square root of 3 over 2, which is the square root of 15 over 4. So this is an example in which functions are given in forms of an integral, and we can differentiate. We know what's happening there. Okay. Okay, another example, let's say number 60. We're given f of x as the integral from 0 to x from 1 minus t squared e raised to t squared dt. On what interval is this function f increasing? On what interval is f increasing? How do I determine, yes, what do I have to find first? The derivative. Right? And when the derivative is blah, the function is increasing. The derivative must be positive for the function to be increasing. Very good. Ready? Good. Please give me f prime of x. Luckily, the upper limit is x, which means I don't have to multiply by x prime. by the inner function prime.
So 1 minus t, 1 minus x squared
Very good.
times e to x squared.
Times the inner function prime, which is 1. So I'm asked now, I'm asked on what interval f is increasing, which means I have to study the derivative, set it equal to 0, find the critical numbers, study the sign, and then make a conclusion. Good. So I have to set it equal to 0. So f prime of x, because this function is defined everywhere. So there is no critical number coming from f prime being undefined. So I set it equal to 0. So I have two options. Not really. 1 minus x squared to be 0 or e to x squared to be 0. But can e to x squared ever be 0? No. So then from here I know there are two options. X equals and x equals. We factor out -1 and we factor x plus 1, x minus 1. So -1 and 1. Again, not sufficient. I need to study the sign of the first derivative. But there is nothing to study here. Why? What is this quantity always? Positive. So since this quantity is always positive, the sign will be given by this. It's a quadratic function with a negative leading coefficient. So in between the solutions is above the x-axis, outside of solution is below. Or just pick a number. Let's pick 0. 1 minus 0 is positive. And outside will be negative. So on which interval will this function, given in the form of an integral, on which interval will it be increasing?
-1.
F increasing on -1, 1. So that's another example in which the function was given in the form of an integral. We differentiated it. We got a function. And we were able to study the sign of that. Sure. Any questions? Any questions? Happy Thanksgiving. Any questions? Okay, this completes the material. There is nothing else. We just have to practice. And I would like to go to the end of chapter 5. Starting on page 417 and continue until bottom of page 418, and just practice. We do not meet on Wednesday, as you know, because school closes at 4 o'clock on Wednesday, this Wednesday.
And homework's due
I did not post any, but it's going to be due following Wednesday.
Wednesday.
Yes. I'm going to post it, and our test is that next Wednesday on the 30th.
Wednesday we go back to break.